Hi guys, welcome again. In this video, I will be showing you how to find the stress in the material. This video is intended for engineering students, especially those who train or screen the materials. Let's begin. The stress is the internal force in the material that resists the tendency of the material to deform or fail when it is acted upon by an external force. Mathematically, the stress is equal to the force over the area. So the stress is represented by the letter sigma, is a Greek letter, because the force per unit area. This force is the applied force that's acting on the material, and this area is the area over which the stress develops. The unit of stress is Newton per square meter or Newton per square millimeter. Let's begin by solving this first problem. The problem is asking you to find the stress in a steel rod. It says a steel rod of diameter 40 millimeter is carrying a load of 230 kilonewtons. Calculate the stress in a steel rod. Let's begin. Solution. Okay. Theta. The diameter of the steel rod is 40 millimeter. 40 millimeter. Okay. It is carrying a load of 230 kilonewtons. So this load is the applied force. For the P equals 230 kilonewtons. Alright. So we are asked to find the stress. Okay. And we know from our formula here the stress is equal to the force over the area. But in a question where the area is not given, but they give us the diameter of the steel. So we can use the diameter to find the area of the steel. We know the area of the steel using the diameter is A equal pi over 4t squared, where t represents the diameter. And pi is a Greek letter. And the value is 3.14. It's a constant. So say A is equal to 3.14 into 40 millimeter or square all over 4. So A is equal to, let's calculate. So the area of this T is 1256 square millimeter. So now we can find the stress. So the stress is equal to the force per unit area. The stress now equal to the force here is 230 kilonewtons. And this kilo is a Greek letter, which means this kilo is a measure prefix, which means 10 to the power 3. So say 230 times 10 to the power 3 Newton all over 1256 square millimeter is equal to. So if we expand this, 230 times 10 to the power 3, it gives us 230,000. 230,000 Newton per 1256 square millimeter. So let's divide this by this. The stress is now equal to 230,000 divided 1256. It gives us 183.12 Newton per square millimeter. So this is the stress in the steel. Let's look at another problem. Alright, our next problem says a box is supported by a cable suspended from a sling as shown in the figure below. Calculate the stress in the cable if the box weighs 350 newtons and the diameter of the cable is 20 millimeters. Alright. So to solve this, let's first analyze this or diagram. This is a box suspended from this sling and is supported by this cable. So therefore there's a force in the cable, the tensile force that is supporting this box. So let's draw the free body diagram, and again the weight of the cable, the weight of the box is acting downward. So let's draw the free body diagram of this figure. The free body diagram. So there's a cable, and look at this, there's a force in the cable that is holding this box. And this is the weight of the box acting downward. Alright, because the weight of the box acts from the center of gravity of this box, which will be here. So P and W. P is acting vertically upward and W acting vertically downward. So if, let me say, according to the equation of equilibrium, it says the sum of forces in the y direction must be equal to 0. That is, force acting up must be equal to forces acting down. So this force acting up P is equal to force acting down W. So the force is equal to W, and W represents the weight of the box, and it is 350 newtons. 350 newtons. So therefore the force in the cable is 350 newtons. From the question, we're asked to find the stress in this cable. And again, the cable is only the diameter. So we can use the diameter to find the area of this cable. They don't find our stress. So the area of the cable is called the circular cable now. Pi t square over 4. Where do you represent the diameter? And pi is 3.14. Diameter is 20 meters. 20 millimeters over 4. Area is equal to 20 square gives us 400 times 3.14 gives us 1256 divided by 4. There's 314. 314 square millimeter. So this is the area of the cable. So now we can find the stress. Now mathematically the stress is equal to the force per unit area, and the force is 350 newtons, and the area is 314 millimeters square. So therefore the stress in this cable will be equal to 350 divided 3.14. 350 divided 314. It gives us 1.11 Newton per square millimeter. So this is the stress in the cable end. Just to let you know, in my calculation, I corrected the area to the second to 2 decimal places. So the stress in this cable is 1.11 Newton per square millimeter. So thanks for watching this video. Please subscribe to this channel for more amazing videos. Thank you.